Need help with GED math word problems? Then you're in the right place. Hi, this is Parker from Test Prep Champions, teaching you how to pass the GED fast. You get started by clicking subscribe down below. So in this video, I'm going to walk you through some hard GED math word problem examples. We're going to go step by step. So sit back, relax, and follow along here. Try each problem for yourself if you want to get the most out of this video. And when you get stuck, watch my solution and I'll teach you how to do it. Let's get started. Okay, question 1. If the ratio of quarters to nickels in a jar is 4:1 and there are 23 nickels, how much money are the coins worth altogether? How much money are the coins worth altogether? Pause the video and try to figure this out, and then we're going to go over it. Okay, so hopefully you had a chance to pause the video and try this question. Let's go over how to do this. So in any word problem, it's really important to first really zero in on what you have to find. So what do we need to find in this question? Well, the end of the question gives it away here, right? It says how much money are the coins worth altogether? So what we're trying to find here is the amount of money in the jar, essentially. So we're looking for the amount of money in that jar. So I'm just going to put, we're trying to find the money in the jar, right? So the total amount of money in the jar. Or in other words, the dollars in the jar. And so we're told here that the ratio of quarters to nickels is 4:1. So once you establish what you're trying to find here, you next want to look at the information that you're given in the question here. And so let me just clarify this. So when I say dollars in the jar, I'm just talking about a dollar value here. It doesn't necessarily have to be like $5 or $10. It could be $10.25, $11.75. Okay, it could be dollars and cents, but I'm just writing a dollar sign here just to keep things short and sweet. So we're now looking at the given information here, and so we're given that the ratio of quarters to nickels in the jar is 4:1. So what does this word ratio mean? Well, a ratio is just a comparison between two things here. So we're comparing the quarters to the nickels. And so the ratio is written here in words. It's written as 4:1. So there are three different ways to write a ratio. So one is just like it's written here, like I've underlined it, 4:1. Now you could also write that as 4, you could use a colon, so 4:1, and you would pronounce this as 4:1. And the symbol here, these two dots, are called a colon. And so the last way to write a ratio would be as a fraction. So let me write that now. So we've got quarters over nickels here, right? Because we're talking about the ratio of quarters to nickels. So I'm going to write whatever comes first here, right? So the first, it says quarters. So I'm putting the quarters on top. Quarters to nickels, nickels come second, so I'm putting the N down here for nickels. And of course, quarters is abbreviated with a Q, and nickels I'm abbreviating with the letter N. And so the ratio of quarters to nickels is 4:1. So let's write that out. That may be important later in the question. So what other information are we given here? Well, we're also told that there are 23 nickels. So let's just write that out here. So we have 23 nickels. So I'm going to put 23 equals N because we know that the number of nickels is 23. Now, what about the quarters here? Well, we don't know how many quarters there are here, so I'm just going to put a question mark here and a Q here for quarters. So now the next step here is to consider what operations do we have to use here. And by operations, I mean addition, subtraction, multiplication, division. We also want to think about equations. Can we write an equation here? So what kind of equation can we write here? Well, let's think about what we are trying to find, right? So we're trying to find the total money in the jar. So in other words, the total amount of money. So I'm just now going to abbreviate that as a dollar sign and the word total. So we're trying to find the total amount of money. So what kind of equation can we write here? Well, what we're really doing here is we're going to look at the total amount of money in quarters, and we're looking at the total amount of money in nickels here, all right? So the sum of the value of the quarters and the value of the nickels is going to give us the total value of the money in the jar here. Okay, so again, dollar sign total, that just represents the total amount of money in the jar here. These are my abbreviations. Dollar sign quarter, what I'm talking about here is the value of the quarters, the monetary value of the quarters in the jar, and the value of the nickels in the jar here, when I have dollar sign and N here. Okay, so now what other kind of equation can we use here? Is there another equation that we can write here? Well, not really, not so far here. So, well, we can take this one step farther here because we know that right off the bat, we know that one quarter is worth 25 cents, right? And so since 1/4 is worth 25 cents, we can write 0.25 times Q. All right, so by this Q, I mean the number of quarters. So when I have $Q here, I'm talking about the value of those quarters. So are the quarters in the jar equal to $3.25? We don't know, but what I mean is the total value of those quarters. When I have the $ in the Q, and the same with the $ in the N here, I'm talking about the total value of the nickels, the monetary value of the nickels here. And so when I just have Q, I'm talking about the number of the quarters here. Okay, and so we also know that a nickel is worth 5 cents, right? Okay, but we also know that there are 23 nickels here. Okay, so if we want to find that total amount of money, what we have to do is we're going to take the number of quarters, multiply it by 0.25, because 1/4 is worth 25 cents, but we don't know how many quarters there are here. And so then what we're going to do is we're going to take the 0.05, which is because a nickel is worth 5 cents, and multiply that by 23. And the reason we're doing it by 23 is because it tells us right here in the question that there are 23 nickels. Okay, so if we do this, this is going to give us the total amount of money in the jar here. All right, and so the only issue here is that we don't know what this Q is. We already know what the nickels are, what the value of the nickels is, right? We do 0.05 times 23, and that is going to give us this $N, right? The total value of the nickels. Okay, but we don't know how to get the value of the quarters because we need to get that Q. And so this is where our ratio is going to come in here. So in this ratio here, what we can do is I'm going to take this ratio and I'm drawing a box around it right now. And I'm going to bring this down here with an arrow. So since we know the number of nickels here, what we can do is we can actually solve for Q just like we would do any other algebra question here. So I'm writing 23 in the formula here where the N is, because we know that there are 23 nickels. And I'm setting that equal to 4/1. So what we're doing here now is we're using a proportion to solve this question. So a ratio just compares two values here, or two quantities, two amounts. And a proportion is just two ratios that are equal to each other. So what we're doing here is we're setting up a proportion and we're going to solve for Q. So how do we do that? Well, we see that we have Q divided by 23. And so if we want to undo that division so that we can get the Q by itself on the left-hand side of the equation, we've got to do the opposite of division, which is multiplication. So let's multiply by 23. So if we multiply by 23, the 23s are going to cancel out, and that's going to give us Q. We're going to have Q by itself on the left-hand side of the equation, and whatever you do to one side, you also have to do to the other side. So we're going to multiply by 23 on both sides. So we're going to do 4 times 23 here. All right, and so you can use a dot to represent multiplication. Okay, so you could also use an X. So let me just show you. If I was going to use that dot, I could also do it like this. I could also just write the X here, or the multiplication sign. Okay, it doesn't really matter however you want to write it, but I wanted to show you both ways, so that's why I got rid of that dot. So we would do 4 times 23, and if you put that in your calculator, you're going to get 92. So we see how many quarters there are here. So how many quarters are there in the jar? Well, there are 92 quarters, so we've got quite a few quarters here in this jar here. Okay, and so since there are 92 quarters, what we're going to do with this 92 is we're going to plug it back into this formula here. Okay, because we now know that there are 92 quarters. So to find the total amount of money in the jar, we're going to do 0.25 times 92 plus 0.05 times 23. Okay, so let me write that down here. So we've got $T, which is the total dollar amount. And I'm not even going to write out that word total because we're going to run out of room as it is here. But we're going to do 0.25 times 92. And again, it's 92 is the number of quarters here. So each quarter is worth 25 cents. We've got 92 quarters. That's why we have 0.25 times 92 plus 0.05 times 23. And let me just recap this and explain my writing here, because we are running out of room on the board here. So this is this $T. Let me highlight this box here so we can clearly see what I'm talking about. We have $T, which is the total amount of money here. So we have 0.25 times 92. All right, and this is a plus sign here, plus 0.05 times 23. So let's put that in our calculator here, and let's see what we get. So 0.25 times 92. That gives me 23. So we've got 23, and then let's do 0.05 times 23. That gives me 1.15. So we add 23 to that, and my calculator gives me 24.15. So let me cross out this ratio here because we don't need it anymore. And I've just found that the total amount of money in the jar is 24.15, so $24.15, and that is the correct answer. Hopefully you got that. If you did, give yourself a pat on the back. Okay, question 2. 3 friends are playing a video game. Jane scores 10 points more than Arnold's, but 6 points less than Sally's. If Sally has 20 points, how many points does Arnold have? So pause the video now and try to solve this, and then we'll go over how to do it. Okay, let's go over this. So this question here may seem complicated, so let's just take it one step at a time. So first of all, what are we actually trying to figure out here? We're trying to figure out how many points does Arnold have. Okay, so what we want to find here is Arnold's score. Okay, so in other words, we're trying to find Arnold's score. And so instead of writing Arnold's score, I'm just going to use an A here. So the letter A is going to represent Arnold's score here. So we're trying to find Arnold's score here. So now we can use the keywords in this question here to help us set up an equation, because the given information is very straightforward here, right? We're given Jane's score, and we're not given Jane's score directly. We're told that her score is 10 points more than Arnold's and 6 less than Sally's. So the only value that we're given directly is Sally's score, which is 20 points. So let me just write an S here for Sally. So Sally's score, I'm just going to abbreviate that with an S. And so Sally has 20 points. So S equals 20. So that's the only number that we know for sure here. So let's set up some equations here. So we see Jane's score is 10 points more than Arnold's. So this word more, right, this is a keyword for addition. 10 points more than Arnold's means that her score, which I'm going to abbreviate with a J. So Jane's score here is equal to Arnold's score, which I'm going to abbreviate with an A, plus 10. So Jane's score is equal to Arnold's score plus 10. Or another way to look at this would be that Arnold's score is equal to Jane's score minus 10. However you want to look at it, either way is fine. You could look at it as Jane's score is equal to Arnold's score plus 10, or you could look at it as Arnold's score is equal to Jane's score minus 10. Okay, however you want to look at it, either way is a valid way to do it here. And so now let's look at what the other equation here is that we can write. So 6 points less than Sally's here. So Jane's score is 6 points less than Sally's. So Jane's score is equal to Sally's score minus 6. All right, but we already know what S is. Remember that S is equal to 20. So we're going to take this 20 here, and we are going to be able to substitute that in for our S here. Okay, so we have Jane's score, which is J, and that's equal to 20 minus 6. So that's simple enough. 20 minus 6 is equal to 14, I should say. Jane's score is equal to 14. So we now found J here. And so what we can do to find Arnold's score now that we have J is we're going to take our J, which is 14, and we can just substitute it into our equation here. Okay, so Arnold's score is equal to J minus 10. So let's do the math here. So Arnold's score is equal to J. So what do I put in here for J? Well, remember, we already figured out that J was equal to 14. So we have 14 minus 10, which is equal to 4. And so that right there is the answer. So Arnold's score is 4. Now, what if you didn't write out Arnold's score as A equals J minus 10? Okay, what if you wrote J equals A plus 10? How would you solve for J? Well, the same thing would apply here. All you would do is write 14 in here for J. Okay, so let me show you how we would do that. So hopefully you've got all this work down, because I'm going to clear some space out. All right, and now we're going to look at this equation here, and let me show you how you would solve for A, or Arnold's score, using this equation here. So what you would do here is we would just take this 14 here, substitute that in for J. So we would replace this, we would rewrite this as 14 equals A plus 10 and we're going to subtract 10 from both sides of the equation here. Okay, and so the reason that we're subtracting 10 from both sides of the equation here is that we have a plus 10, and we want to undo this 10. We want to get rid of the 10. Since we have addition here, we undo addition with subtraction, so we're subtracting 10 here. That's going to give us a by itself on the right-hand side of the equation, and we're subtracting 10 from 14 because whatever we do to one side, we have to do to the other side. So we subtract 10 over on this side to undo the addition, so we get a by itself, and so we also must subtract 10 on the other side, which is going to be 4. So 4 equals a here. So either way, whichever way you wrote the equation, we see that 4 is the answer. So if you looked at the sentence, Jane scores 10 points more than Arnold's, you could write J equals a plus 10. That's one way to write the equation, or you could look at it and you could write it as Arnold's score. So you would write A equals J minus 10. Whichever way you did it, as long as you got 4 as your answer, then you got the correct answer. Okay, question 3. Bradley walks 25 yards south from his house to his friend's house. He then walks 10 yards west to get to school. If tomorrow Bradley walks straight to school without stopping at his friend's house, how far will his walk be in yards? Round your answer to the nearest whole number. So pause the video and try this problem out. Okay, so let's go over this. So this is a question here where we're first of all going to have to make a map here. So let's say that this is Bradley, all right? And so Bradley starts out at his house here. So let's say that Bradley's at his house here. And so where does he go? Well, he walks 25 yards south. So think of a compass here, right? So on a compass, we've got these 4 directions here. And so we've got north up here. We've got south down here. We've got east over here. And we've got west over here. Okay, and so the way that you can remember these if you're not used to looking at a compass is just think, from the United States, we know that up north is Canada, and down south is Mexico. Now, on the East Coast, we've got cities like New York, Philadelphia, and in the West Coast, we've got California. So just remember, we've got north, south, east, and west. If you're not used to looking at a compass, just remember your basic directions here. So starting at Bradley's house, right? So let's say that this is Bradley, and let's say that this area right here, this little dot represents his house. So he goes down 25 yards. So we start at this dot and we go down 25 yards. And then what does he do? Well, he then walks 10 yards west to get to school. So he walks down 25 yards south, right? And so then let's say right here, this is Bradley's friend's house. Okay, so let me draw a little house here, and this is Bradley's friend's house. And so no, we're not going to FaceTime. This is Bradley's friend's house here. So Bradley decided he didn't want to FaceTime. He wanted to go stop at his friend's house in person. And it's a cold day wherever they're living, and so they've got a fire going, a nice little chimney there. But anyway, so this is Bradley's friend's house. And so then he goes another 10 yards going west here, and then he gets to the school. So let's just say that this big building here represents the school. And maybe they've got a little flagpole out front. Maybe not, though. But anyway, this is the school here. So right here we've got the school. So let me represent that with another dot here. Okay, and so this is 10, right? So this whole line here is 10 yards. So this is the map of Bradley's walk today. So he starts at his house, walks 25 yards south, goes to his friend's house, then he walks 10 yards west to get to school. But what if tomorrow he just goes straight from his house to school? So let's say he goes right from the school, or right from his house right to school. All right, so this is approximately, let me try to make that line a little bit straighter. So this is the path that he would take. He starts at his house and goes right to the school. He doesn't go south to his friend's house and then west to get to the school. He just goes as straight as possible right to the school here. All right, so hopefully what you're seeing here is that we have just drawn a triangle here, particularly a right triangle. So whenever you see a triangle with a little box in the corner, this little box type thing in the corner tells you that you've got a 90-degree angle here. And a triangle with a 90-degree angle is what we call a right triangle. So let me now get rid of our north, south, west, east, our direction marker over here, because we won't need it anymore, because it's really important to understand the Pythagorean theorem. So when I talk about the Pythagorean theorem, it might sound like I'm speaking Greek, and I actually am speaking Greek, because Pythagorean theorem comes from a great Greek mathematician and philosopher and all-around intellectual, but that's really not the point here. The point here is to talk about what's called the Pythagorean theorem, which applies when you've got a right triangle. So let's look at right triangles here. This is very important for your GED test. So when we've got a right triangle, all right, there are three different sides to this triangle. So we've got we can call this side side A, we can call this side side B, and this side side C. All right, and so there's a formula that I want you to know how to use for your test. The formula is a squared plus b squared equals c squared. And it's very important to understand this formula here. Okay, and so what this formula tells us is that if we square the value of side A and the value of side B and we add them up, we're going to get c squared here. All right, and so on our triangle over here, what we can say is that our 25, we can say 25, and let me get the smoke out of the way here. Let's say maybe it warmed up and they don't need the chimney on, so now they don't have the smoke coming out of that chimney. And so you know what? We know where the house is now. We know where the school is, so let me clear this drawing out here so we can make some more room here. All right, because this is the point now. The point here is that this 25, we can call this side A. And this 10, we can call this our side B here. All right, and so this side here, which is Bradley's path from his house right to the school, is our side C, and we don't know what our side C is. So we're going to use this formula, a squared plus b squared equals c squared. We're going to do a little bit of math here, and we're going to be able to find out what C is. Okay, so I'm going to clear some more space here, so make sure that if you want to put this in your notes, you get this right triangle here. Okay, if you don't have it in your notes, that's okay. You can pause the video or you can rewind after the video, but I'm going to clear that out to make some room here because we're going to do a calculation. All right, and so we've got a squared plus b squared equals c squared. So 25 is equal to a here. So in the formula where we have a squared, instead of writing a squared, we're going to put 25 squared. All right, and again, why 25 squared? Because 25 is equal to a, right? And so therefore, in our formula, we're going to take our 25 and substitute it in for a. So we're going to replace this a with 25. Okay, and we're going to do the same thing with b. So we know that side b is equal to 10, or 10 yards. So we're going to take this 10, we're going to go up into our formula, and we're going to replace b with 10. So if we do that, we have 10 squared. And this is all equal to c squared here. All right, so hopefully you are following this so far. If you are, good job. If not, then you might want to rewind a little bit and make sure that you understand this because this is important for your test. So 25 squared, to get that you would just do 25 times 25, or you can use your calculator, but 25 squared is equal to 625. And 10 squared is equal to 100. And again, to get 10 squared, you can just put 10 squared into your calculator or do 10 times 10, or just remember that 10 squared is equal to 100. Okay, so 625 plus 100 is equal to 725. So what have we just figured out here? Did we find C? Is the answer 725? Well, think about it. Does that make sense here? So if we're talking about yards, 725 yards here. So how big is a football field? So an American football field is 100 yards. So 725, that's 7 football fields plus an extra 25 yards. So does that make any sense? Would his walk really be 7 football fields plus another 25 yards? If to get to his friend's house, he's just going 25 yards, and then to get to the school from there, he's going another 10 yards. So he essentially has a 35-yard walk. All right, so if it's a 35-yard walk, if he goes from his house to his friend's house, then west, rather than going directly to the school, would it make any sense that going from his house into the school, all right, is going to be 725 yards? No, that wouldn't make any sense, all right? And the reason is because the 725 is equal to c squared. So 725 is equal to c squared, but we don't want c squared, we just want c. So we've got c squared is equal to 725 here. Okay, and so what we're going to do here, since we have c squared, we need to take the square root of both sides. So whenever you have any number or any value squared here, like c squared, if we take the square root of that, we just get c. Okay, so we're going to take the square root of both sides, because whatever you do to one side, you have to do to the other side. Okay, and so if you do the math, what you're going to do is in your calculator, you would hit the square root symbol, put in 725, and what you're going to find is that the number is going to round to 27. All right, so approximately 27 yards is our answer here. So 27 yards. So let's just think, does that make sense? So if he goes, remember his first route, if he starts at his house, it goes 25 yards south, then 10 yards west. His first route was about 35 yards, right? But if instead of doing that, he just walks straight from his house down to the school, and that's 27 yards. Does that make sense? Yes, that sounds about what we would expect. So the answer here is 27 yards. So what we've done here is we did the math here. We got our answer, which was 27 yards, and we asked, does this answer make sense based off of what we've got in the question? And if we use some basic common sense here, yes, it does. Okay, question 4. Joe gets paid $425 a week at his job. Every week he gets $129 in taxes and $50 in insurance payments taken out of his paycheck. How much money does he keep each week? Pause the video and try this problem out, and then we're going to go over it. Okay, time to go over it. Hopefully you had a chance to try this. So as always, let's think about what do we need to find here. So before you do any word problem, always make sure you're clear on what you have to find, because if not, then you might waste your time on your test doing calculations that are not going to help you get the right answer. I've seen a lot of students go into the test, read a question and not fully understand it, and then waste their time, waste valuable minutes doing calculations, and they calculate an answer, they do a brilliant calculation, but they've calculated some number that is not the answer because they didn't stop and double check or even triple check what they have to find here. So here, we have to find how much money he keeps each week. So what we're trying to find here is the money kept, or in other words, the money that he gets to do whatever he wants with. So the money kept. All right, so we're looking for the money that's kept. So for any word problem, start with looking at what you have to find. Next, look at the given information here. And so the given information is always very simple because you just look at the numbers that you're given. All right, so how straightforward is that? So he gets paid $425 a week, and he gets $129 in taxes and $50 taken out of his paycheck. All right, and so what does this word taken out mean? Well, taken out, that should tell you that there may need to be a subtraction done in the question here, because if money is taken out of his paycheck, that's money that's being subtracted from his paycheck. So in other words, this is money that he's not going to get to keep. All right, so can we set up an equation here? And the answer is, of course, yes, we can. So how much money does he get to keep? Well, here we can see that the amount of money that he keeps here. So let me just put money that gets kept, or that he keeps. So the money kept is equal to what he gets paid. Okay, so he gets paid that $429 a week. Or $425 a week. All right, but then he's going to lose $129 in taxes. And then he's also going to lose his money in insurance payments. All right, and so here our equation is just that the money that he gets paid each week, which is a $425, and then we also have to factor in that he's going to get $125 taken out in taxes, and also that he's going to get $50 taken out here in insurance payments. So what is left over after that? So that's what we need to figure out here. So we would then do on our calculators 425 minus 129 minus 50, and the math will tell us that the money kept is equal to $246. All right, and now there's got to be somebody out here who's watching this right now. Perhaps it's you. So maybe what you did was you added 129 and 50, and then you subtracted that from 425. So let's do that here. So let's say that you did 129 plus 50. Okay, so I'm just going to draw. Let me just make some space here, and let's see what kind of answer we get if we do it that way, because I know that there's somebody out there who definitely did it this way. All right, so if we do 129 plus 50, what does that give us here? Well, 129 plus 50 gives us 179. So you might have said to yourself, well, I know that I've got to subtract the taxes and the insurance. So let me add that up. And that gives us 179. And then what you did was you did 425 minus 179. So what answer does that give us? What answer does that give us? Well, what you'll see here is that you're also going to get, what you get is 246. So either way, you're going to get 246. So either way you think about it, you'll get the right answer. And so why did I just write 46 here? That would be a pretty bad paycheck. So it should be 246. I'm not sure where that 2 went. But the answer is 246 here. Okay, and so one takeaway here, and hopefully you got the work here. So I want to make sure that we emphasize the answer here, that is 246. And so one big takeaway here that I want you to get from this question and also this video is that a lot of word problems here are just using common sense. So what you've got to do is you've got to look at what you've got to find, which we did, look at the information that you're given, and then from there, what you want to do is think about the operations. Look for keywords like we saw taken out here. So keywords can tell you, they can be clues to if you're going to subtract or add or multiply or divide. And you also want to think about making some kind of equation. Sometimes you'll need to make multiple equations. And then from there, you'll do the calculation and hopefully you'll get the right answer. But really, at the end of the day, you've just got to try to reason your way through the questions here. And the more practice you get, the better you'll get at doing that. And so I just want you to see here that when you're reasoning your way through the questions, there's usually not just one way to look at it. And so however you looked at this question, if you just wrote it 425 minus 129 minus 50, or if you did 129 plus 50 first, and then you got 179, and then you subtracted that from 425, hopefully we see here that we got the same answer here. So in Kingsport School, 46% of students are female. If the total number of students is 1250, then how many male students are attending this school? And it's out of a practice test. All right, so give this one a try. I'm going to be right back. All right, not even a minute. I'm back already. So let's do this. Let's go over this. So anybody have any idea how to approach this question? All right, so the total number of school is 1250. How many male students are attending the school? Okay, so in this case, this question is a little bit different than what we were just looking at here. So I don't want to spoil it if anybody's taking a stab at this, but basically it's a little bit different, but it's kind of the same idea. So the first thing that we need to do is we just need to make an equation here. So this should be common sense, but so we've got, okay, so let's say we've got our female, which I'm going to just abbreviate as F. We've got females and we've got males. All right, and so that's going to equal, the total number of students, right? So our total number of students, all right, we get that by our female and male, so the total students. And so in order to answer the question, which is how many students are male, all right, we've got to find this M here, all right? And so whenever we do word problems, let's make sure that we're crystal clear on what we need to find here. Yep, we will use a percent equation here, yes. A little bit different, but we are going to do that too, yes, because we will have to get the number of females. So yep, that's right. That'll be part of this here. Yep. Yes, you're getting it. Yes, you're getting it. Yes. Yeah, exactly. Okay, so let me just make sure we're all on the same page here. So what we're finding here is M. So we're trying to find the total number of male students. And so we do know what the total number of students is because it tells us. So we already know this. So we know the total number of students is 1,250. So we don't know M, that's what we want to find. And we don't know F, we don't know the female, but we can find that here. So yes, so we've got 46% of the students are female, and the total number of students is 1,250. So we want to find the percent of students that are, or we want to find the number of students that are female. So if you remember, that formula here is over of, and so really this formula is just here to help you guys until you start to understand how to do it without the formula. So is over of equals percent over 100, because it is a little bit slower to use the formula, but it will get you the right answer. So you can stick with this formula, you can use it the whole time to get your answer, but you don't necessarily always need to do it this way, but this is just good to help you guys get, you can always do it with this formula. It doesn't really matter here, but so let's plug in some numbers here. So our percent is going to be 46. And so we do know here the total number of students is 1,250. So in this case, our of is our 1,250, right? And so we don't know the percentage of girls, right? So that's what we're trying to find here. So what percentage of girls, or we know the percentage, we know the 46% of girls, and we want to know how many actual girls there are here, how many females, right? So I'm probably confusing you guys because I've been at this for a while here. But basically, we're going to put an X in here for our is, and our of is our 1250. And here we've got our 46%, right? So we've got 46 over 100. And so yes, all you would have to do for 46 over 100, you could just write that as 0.46 as, all right, so you could just, yes, you could write that as 0.46. And then yes, we are going to cross multiply here. So we would do 1250 times, you could do 46 divided by 100 first. But basically the idea here is that you're just going to do, where's my calculator? You would do 46 times 1250, divide that by 100 if you do it this way. And, oh my God, my calculator just died. 1250 times 46. Okay, so the answer here, so did anybody get X? What'd you guys get? I just got X is 575, but then again, my calculator just kind of died halfway through. So that's, anybody else get that answer here? Let me double check it again. So the fast way to do this is just to do 0.46 times 1250. That's the fast way to do it, which would give you 575. So the fastest way to do this is, so like I said, that formula is just here to teach you the fast way to do it. So this formula helps you set it up so that you can do it the fast way. But the fast way to do it is to take this. Yep, exactly. Yeah, easy. 1250 times 0.46. So yeah, that's the fast way to do it. See this 46% is 0.46, and then you just multiply that by, or by 1250. And so that's how I got that 575. So is everybody clear on how I got that 575 here? 575, but we're not quite at the, that's our girls, right? So that's actually, instead of the boys, that's our girls. But the 575 is the right number. And so what we just found was, because it tells us the number, because 46% are female. And so when we, yep, you're right, perfect. Yep, I knew exactly what you meant. So our number here is just 575. So we now have this 575 plus m equals 1250. So all we do now is just do subtraction. And let me get this out of the road here. So basically, we just do a subtraction problem now because we've got 575 plus m equals 1250. So we just subtract by 575 on both sides of our equation here. Let's see if my calculator can survive this. I don't know why in the world it's kind of dying out here. 1250 minus 575, 670. So m equals 670. So that's how you would get the number of males. So it's really, you're just doing a percentage problem, but first you just had to know to set up this equation. All right, so does that make sense, everybody? Any questions on this? Seems like you guys were following this pretty well here, so it seems like you guys got this seems like you guys understood that pretty well. And so this is actually a great example because this is kind of a typical question. Like, you definitely might get something like this on your test. This is a pretty typical example.